Now I want us to take some time to look at the area of a triangle. And the area of a triangle, we're going to start with this triangle, triangle A, which is actually a right triangle. Right triangles are very special triangles. It's a right triangle because it has a right angle. You see me put a square in it right here. That angle is 90 degrees. And those are great because a right triangle always is exactly half of what we would call its related rectangle. What you notice here is we actually have a rectangle which has four 90-degree angles, and we just have a diagonal across it. The diagonal is a line that goes from one corner to the opposite corner, and it forms two equal triangles. And so the reason that makes it so easy to find the area of a triangle is because we can actually just find the area of the rectangle and we can take half of it. And so we recognize that the rectangle goes 1, 2, 3, 4, 5, 6 units. And it has a height of 1, 2, 3, 4, 5 units. Which means the entire rectangle is 30 square units. And so all I would have to do to find the area of the triangle would be to take half of that. And we know that half of 30, well, that's 30 divided by 2, and 30 divided by 2 is 15. So we could say that the area of triangle A is equal to, we could go with 30. Let's call the unit centimeters, so we'll say it's 30 square centimeters. Remember, it has to be square units because we're talking about area. And what I want you to notice on this right triangle is that it's actually, if we consider the area of a rectangle, the length times the width, or we're going to actually change those words for triangles and say that it's the base times the height. That's the area of a rectangle. Then all we need to do is do half of that to find the area of a triangle. I want you to write that formula down, that it's 1/2 times the base times the height. And we've seen that it works on a right triangle. We're going to try it on the other ones. Now some of you are going to say, well, you could do base times height divided by 2. And you're correct. That's actually the same thing. There's a reason I write it as 1/2 times base times height, and all math books do. It's because when we have multiplication, sometimes we can change the order to make the problems easier. In this case, for example, we could have said 1/2 times, the base was 6, times, and the height was 5. Well, I can do this in any order possible. And so some of you may actually say, well, half of 6 is 3, and you could have just done 3 times 5 to get 15. And that's the reason for that. Now let's try some other triangles that have some slightly different shapes that aren't right triangles, and see if 1/2 times the base times height works for them as well. So now let's look at triangle B. Triangle B is slightly different than triangle A. Triangle A was a right triangle. Triangle B is actually an acute triangle. And the reason we call it an acute triangle is because we notice that every angle inside the triangle is an acute angle. And so it actually still fits in a rectangle as well, but it doesn't fit as a diagonal. And so it doesn't look like it necessarily takes up exactly half of the rectangle. So we're going to try to look and see, does 1/2 times the base times the height work on this acute triangle? And so the first thing we need to do is actually look at the rectangle that's in here. Now I want you to notice something, that this triangle also has a base and a height, but there's something we notice about the height. The height of the triangle is not one of the sides. And so a base is one of the sides. For example, on this one, I'm going to do it in red. The base goes from one corner to another corner, and the base is a side. And I always put the base at the bottom. The truth is, you could turn the triangle and the base could be any side. But the height is actually the distance from the furthest corner straight to the base. We call it the perpendicular distance because perpendicular lines are lines that make 90-degree angles. So the height of this is actually from the top all the way down where this green line is to the bottom. There will always be a right angle where the base and the height meet. You could think of it as a mountain. If this were a mountain and you climbed to the top, the height would not be one of the sides of the mountain. The height would be the distance from the top of the mountain all the way straight to the bottom, 90 degrees with the ground. And that makes it have the same height as the rectangle it's in. So let me do the rectangle. I'm going to do the rectangle in, let's do the rectangle in, I'm sort of colorblind, but I think this is sort of an orange or maybe even a peach color. If we have the, this is definitely a tan. If we have the rectangle here, we could call it the related rectangle. We notice that the rectangle is 1, 2, 3, 4, 5, 6 units. We'll call them centimeters. 6 centimeters is the base, and then the height of the rectangle is 1, 2, 3, 4, 5, 6 as well. So our rectangle is actually a 6 by 6 square, and it has an area of the area of the rectangle. I put area of rectangle is 36 square centimeters. Okay, so my question is this triangle, does it take up exactly half of the square or the rectangle that it's in? And actually, because I've drawn this height, it's actually pretty easy to see that it is. So if I go ahead and take where I drew the height and make a rectangle here, I notice that exactly half of this green rectangle, let me stripe the green one so you can see, exactly half of this rectangle is in triangle B. And then if I go on the other side and I make another rectangle, so I'll come here and I'll make it blue, and I'll do this one, then what I find out is exactly half of this blue rectangle. You notice that this is now a right, it's got a right triangle, and with the diagonal it's exactly half. And so the triangle on the left, half of it is in the rectangle on the left, half of it is in triangle B, and the one on the right, half of it is in fact, we could say this, the blue is 4 by 6 is 24, so right here we have 12 square centimeters inside this triangle. I have 12 square centimeters. And then if I go to the other side, inside this triangle, well, I see that I have 2 times 6. There's 12 over here in this rectangle, which means this triangle should be 6 square centimeters. And if I add them up, 12 and 6 should give me a total of 18. So I could say that the area of triangle B is 18 square centimeters, which is half of the rectangle. And so the question I asked a minute ago was, I actually said, does 1/2 times the base times the height work for area of this triangle, even though it's not a right triangle? And we said that the base was 6 and the height was 6. We know our answer should be 18 because we've counted it. Well, look, half of 6 is 3, and 3 times 6 is 18. And so we know that 1/2 times the base times the height really does work even for this triangle. Finally, let's take a look at triangle C. Triangle C, as you can tell, is actually neither an acute nor a right triangle. It's an obtuse triangle. The reason we call it an obtuse triangle is because it has an obtuse angle. You can see it right here. And obtuse triangles don't fit inside a rectangle with the same base and the height. We can see that it does have a base, which is the side of a triangle, and it does match a rectangle. And we notice that this triangle has a height that goes from the top, and when I actually do the height straight down, if you can imagine this as being a mountain, the height is not the length of one of the sides, and it's not going to go into the base of the mountain. But if I went straight down, how high is this mountain? Well, I could extend this line, and I told you before that the height always forms a right angle. And so this looks to me like it probably is not the exact same area as half of the rectangle. But we notice this rectangle has the same base, and it does have the same height. And this is going to be harder to demonstrate on video, and so what we'll do is we'll come back in class and we'll actually draw this on graph paper, and we will cut it out with scissors and re-glue it. But let me just for right now show us that I could actually draw half of this rectangle. So our rectangle has a base of 4, we'll call them centimeters, and a height of 6 centimeters. And so we recognize that this rectangle has an area. I shouldn't have put, I'm sorry, I made a mistake. I should not have put square centimeters. The height is in centimeters. The area will be in square centimeters. But it has an area, the rectangle, of 24 square centimeters. I think that's the area of the rectangle. is 24 square centimeters, which means that if 1/2 times, if we have been saying that the triangle takes up half of its related rectangle, it'll be a rectangle with the same base and the height. And so what we actually find is it should be able to fill up this circle. And like I said, this is going to be very, very difficult to demonstrate on here. But if I took this triangle and I could cut it and turn it, it would fit in here. And then this triangle right here that I'm doing in this yellowish color, I could slide it and it would actually fit in here. And so I'll go ahead and tell you, and we'll practice it in class to prove that it's true, but that actually this triangle we could also do 1/2 times the base times the height. And we would find that half of 4 is 2, and 2 times 6 is 12, and that triangle C has an area of 12 square centimeters. And so we'll practice that. But just to know, the thing I want us to get from this is if we want to find the area of any triangle, here's what we have to do. We have to find the base, and the base will be one of the sides. And we have to find the height, and the height will be a distance from the other side of the triangle to the base, and it's always perpendicular, which means it forms a 90-degree angle. And if we multiply those together, we would get a rectangle. But we've said that every triangle is actually 1/2 of its related rectangle. So if you want to know how to find the area of a triangle, it does not matter what kind of triangle, we can always do 1/2 times the base times the height.